Okay, so let me correct my typos what I saying in the first video. So this migrations is not the migrate the contract. It is for the travel. So we use travel to run the contract, to do some testing. So here is just for travel to take it to do some the steps recorded when run travel testing. So but it is indeed there is migrations contracts in the when the unit swap to migrate from V2 to V3, there are indeed migration contracts to do it. So if you are interested, you can explore it in their Uniswap GitHub. So that's for migrations. So next is for there are two main contracts we are introducing. So first is Sloppy Factory is inherited from its interface as well. And this contract is to do the sloppy pair creation and store the sloppy pair address into this contract. So it's easy to to track the sloppy pair address when indexing when you know the two token addresses. First is a constant called init code pair hash. So if you do the search, so there is only one here, and nowhere and no other contracts will use this hash. And but it's not mean is not useful, is useless. No, because it will use it for sloppy router if when we introduce later. Uh, but I'm not sure sloppy router will use it, but the Uniswap v2 will take use of the unique code pair hash. So if you see the hash, it is the encodes the creation code of the sloppy pair contract. So like there is a way to get its creation code and one unique random number and two token address. So if we encode all of the information, we can get the final address, final final Uniswap pair address. Yes, there are some hash calculation in Uniswap pair. So it will take use of the pair, this unique code pair hash to calculate the pair address instead of just checking the reading the sloppy factory. So that's the use of the hash. In this case, we don't use it in sloppy. I believe so. If you use it, well, I will introduce later. And there is another to address is phi2 and phi2 setter. So phi2 setter will set is the setter of the phi2 address, which means whenever we do some swap and all of the fees will flows into phi2 address, and the fee setter will set the address. is kind of admin role in this contract. And next one is important one, is get pair. We see there's 2D mapping, and the index is to address, which means the addresses of the two ERC20 tokens, and we will get the sloppy pair contract address. And all pairs is just install all of the pair addresses created from the sloppy factory. We found there is an event called pair created. Will emit the events whenever one pair created, which is easy, easy to track the the pair creation flow, by some service. And constructor just sets the v2 setter only, and that's it. And we have the length of the all pairs array. Well, actually we can directly invoke it by this one. It's also I think I think it's not supported anymore. Doesn't matter. So we need read this function to get the total length if needed. Next is the important one called create pair. We need, so the arguments is just token A and token B for ERC20 token. So first, the cannot be, the two tokens cannot be identical, of course. And second is sort the token. So we just, compare the two address, hex value. So the smaller is the first, we call token 0, and the larger one is called token 1. So in this way, we will create, a unique pair address. So we need sort it out, and also it will like when do the pair address calculation in sloppy router is also very necessary to in some sorted sequence for token 0 and token 1. So first, and check the smallest one must not be 0, of course, because there's no 0 address as a token, as a contract. Also check the existence. So it must be 0 in this array. And then we will get the creation code, as we mentioned before. So the creation code is just, whenever we deploy the sloppy pair contract, the data is creation code. Actually, it's called deployed creation code, and the creation code it will be, after deployed by a constructor, and the creation code will exist in the on-chain storage. So the creation code is this there, and we do a random number. So encode the two tokens with a hash, and do a hash with into a 32 bytes, and this number is a unique number forever. And we use assembly block code block and invoke create2 opcode. So create2 will the difference between create and create2 is the number there is a number as an argument in create2, so make it unique. So here, do some operations, loads the code, and some I forgot the details of each argument. So in this way, with unique number, we will create sloppy pair addresses, and there is and the return is the address. After that, we need invoke the initial function, and we introduce later how to so how does it work? So first initialize the token with token 0 and token 1, and then record it into a get pair array. So the token 0, token 1, get pair token 1, token 0, get pair 2 for easy to read. And all pairs also push the pair address as well, and emits the pair created event. Here is set the v2. The message sender must be a v2 setter address as declared in the constructor, and then reset to v2 address and emit the event. So if we want to transfer our v2 setter row to others, we need we ourselves must be a v2 setter, and we can transfer to others. And finally emit the event as well. So that's for the sloppy factory. Let's talk about the sloppy pair, which is the most important part of the sloppy core. So first, you will import the sloppy pair interface, the sloppy ERC20 contract, and math libraries, and ERC20 token interface, which will be used to two token 0 and token 1 operations. Same for sloppy factory to get the v2 address. Last one is for the sloppy call to invoke some functions from the user side. We will introduce later. So first is sloppy pair is inherited from sloppy pair, of course, and we will override all of the functions from the sloppy pair. And also sloppy pair is sloppy ERC20, which means sloppy pair is the sloppy pair share ERC20 token. So for uint or uint256 is the same. We use SafeMath. And if we use uint224, we will use these libraries to encode and decode. First, we declare the minimum liquidity, which means whenever the user adds the liquidity, it must be greater than some value. And here we said it is 1,000. And there is a selector. This is the method ID. We call it method ID in smart contract level. It will invoke the transfer function prototype. Do the hash function and select the first 4 bytes. So we call it selector, and it will be used to do some call, do some call function let's introduce later. And the factory is the sloppy factory. Token one is token zero is token zero. Token one is token one. ERC20 token standard. So these two are the two tokens we mentioned before. Two tokens, which is stored into the sloppy pair. And reserve zero and reserve one is the record to record the current reserved amount of the token zero and the reserved amount of token one. And this is get the last the update last sloppy pair update timestamp. Price zero cumulative loss is the price of the token zero but is cumulative, and it's the same as the price one. And K last is the K as I mentioned in the first video, the first introduction video. So we know X times Y is equal to K, and K is a environment. So that is the K. So here is the comments. So it should be equal to reserve zero times reserve one. And whenever add or remove liquidity, this K last will be updated. So there is another variable called locked, which is like so if we see the modifier, so it must be unlocked must be one, and then it changed to zero and underscore, which means implement the function, and then reset unlock to one. So which means if unlock is zero, all of the lock modifier functions cannot be executed. If it's one, it will be executed. And during the execution of the function, the alloc is zero. So this for lock variable. First is some read functions. This one is called get reserves. So it will return the reserve zero, reserve one, and last update timestamp. And same transfer. If this is private functions, will be not visible for the external addresses, but it will be used in the contract. So in this function, you will see you will use a call function. The call is built-in function in Solidity. So the token is some ERC20 in convention is ERC20 token address, and it will invoke some function. So the arguments is the ABI encoded hex number. The selector is the the transfer function first 4 bytes, and combined with the to address and address 2 and the value to be transferred. So after encoded, whenever the token is called, it will transfer to some address, and the message sender will be the sloppy pair address, because the call happens inside the sloppy pair contract. So the return variable is, the first is success, another is data. So the success, if it is success and they, I know if it's success and there's no error, data will be 0, and which means it's success. But actually, if it returns true, it succeed, of course. So here you just check is transfer successes or not. So that's called safe transfer. So we use it. So what we avoid the DAO transfer function, because we care about some the fallback function. There are no enough gas, or there's gas limits for invoke fallback functions. So it's kind of, it's not safe to use a transfer. It's better to use .call. So here we use .call to do a token transfer. And there are 4 events. The first is mint, second is burn. Mint is as we know it. So whenever the sender has some liquidity, we will emit the mint function. It will, which means it will mint the corresponding amount of some amount of the sloppy pair shares to the sender. And burn will burn the shares and send the 2 tokens to the 2 addresses. And swap is the same, is similar. So sender can do swap A to B, and it will, get in. So amount 0 and amount in will be 0 for one of it, and the other is there are some value, and which is same as here. It will amount one of the 2 variables will be 0, and the other has some value, and the out amount will be sent to 2 address. And sync events will happen in the swap, or add and remove liquidity. It will, the sync the current balance of the swappy pair of token 1, token 0 and token 1 to update for reserve 0 and the reserve 1. And the constructor just set the factory as the message sender, because the factory all do the creation, right? So it will involve the create tool. So the message sender will be the factory inside of the, the designer, smart contract developer. And here is the initialize function, which happens after do the creation in Sloppy factory. So it will, as you see, the factory must be message sender and store the token 0 and token 1 addresses. And remaining is for the internal functions. So we can jump it to, because we need a high level idea how to do it. Yeah. So let me have a break, and we will see the next video.